This week, the Japanese car manufacturer Nissan announced that it was going to build an electric car battery plant in the UK, potentially creating thousands of jobs both in the factory itself and in the downstream industries associated with it. Now, this announcement is important on a number of levels. First of all, because post Brexit, any good news about industry and jobs is very helpful, because Brexit was obviously supposed to herald a new dawn for British industry and the British economy. It's also interesting because the UK has already announced that it will ban the sale of petrol-driven cars by 2030, so all cars sold after that date will be electric. And also in the news this week was the fact that there's a shortage of batteries for electric cars in Europe at the moment, and a number of car plants have had to stop production because they can't get hold of the batteries they need. So all of this led to me to give a little bit of thought to these car batteries that go into electric cars, which are of course different to the batteries that go into normal cars. And it led me to the issue of rare earths. Now, the rare earth metals are a group of metals in the periodic table that have a number of interesting properties. And it just so turns out that they underlie a lot of the green technology that is coming through at the moment, particularly the batteries for electric cars, but also the generators for wind turbines. Interestingly, although they're called rare earths, they're not actually that rare, but they are extremely difficult to get out of the ground. But I'll come back to that in a minute. So I think it's worth just mentioning very quickly how an electric motor and how an electric generator works. They both are fundamentally dependent on magnets. So a motor will turn electricity into motion by using wires and a magnet. A generator does the opposite. It turns motion, it moves a wire through a magnetic field, and through that creates electricity. I'm sure you can remember having done this sort of thing back at school. But the magnets are the fundamental thing. And these, the better the magnet, the better the performance of the motor or the generator. And so, since rare earth metals have very good magnetic properties, they're very much in demand for batteries and generators. The trouble is, however, that getting these rare earths out of the ground, as I've said, is an extremely difficult process, and it's extremely bad for the environment. One reason for that is that the rare earths are not found alone. They're usually in an ore with some other type of rock, a less valuable one. Indeed, you need to extract thousands of tons of normal rock just to produce from that a few kilos of a rare earth metal. And not only that, you need a good deal of chemicals to process the rock in order to get the rare earth metals out. Also, there's an awful lot of water involved in the setup. So it's very damaging for the environment. And not only the environment, there's also a serious health risk to humans in the extraction industry around rare earth metals. I mentioned the fact that you need chemicals to get the rare earths out of the ore that they're found in. Some of those are just plain acids, which are very dangerous for the workers that use them. Some of the ores from which the rare earths are extracted are radioactive, and that obviously is also dangerous for the workers that are doing the job. And all of that also will end up as wastewater that then seeps into groundwater. And that you have a secondary problem. Not only the miners actually working in a mine extracting rare earth metals suffer health risks, but just normal inhabitants living nearby might also suffer. And this is very much why certain countries like China are now leading production in rare earth metals, because they are perhaps a little bit less fussy about environmental regulation and worker health than countries in Europe and the US. Not many people know this, but in the 1980s, the US was the leading producer of rare earth metals in the world. But as environmental and health protection regulation became stricter, it became more expensive to mine these rare earth metals. And so they gradually closed down their mines and let the Chinese do the dirty work. In countries like China and the Democratic Republic of Congo, where some of these rare earths are mined, you don't have protective equipment for workers. You don't necessarily have safety rules. You don't have statistics on worker health or worker safety or deaths. And in some places, you'll even have child labour. But we know about these problems, and just to highlight that we know about them and what we can do about them, I'd like to read to you from the OECD report that I handed out a moment ago. If you could turn to page 39, please. I'd like to read to you from point 5. What can be done to better protect workers, particularly those in the informal part of the industry? Objectives include A. The avoidance of exploitative labour practices, including the use of child labour. B. Ensuring that wages properly reflect the value of the work done. C. The adoption of safe working practices. D. Provision of care for those harmed through their work. The difficulty here lies in ensuring that those that such a policy seeks to help are not further disadvantaged by being pushed further into the margins, losing their current source of income and being left worse off as a result. This will require close working with the affected communities. One possibility is the development of a certification system that could be funded by product manufacturers to ensure that their supply chain meets high ethical standards. It was noted that data on occupational hazards are of limited availability in some countries. This is true even for mining, an occupation for which the health risks have been recognised for decades. Data on the risks of artisanal mining and low-level secondary materials recovery are particularly lacking, despite the fact that the workers involved in these activities are at the highest risks. This applies even when activities such as shipbreaking are carried out on a major scale. Better data would facilitate dissemination of best practice in a more targeted manner than is currently possible. 6. Adequate compensation systems in place for individuals and communities who suffer the consequences of poor health and a damaged environment. 7. How can best practice for protection of workers, local communities, and the environment be more effectively disseminated? Safe working and good environmental performance is as routine in some regions as the lack of it is in others. It's noted that poor practice is not confined to companies operating in their own countries, but includes external investors that do not operate as they would be required to do in their domestic market. End of quote. I think this report shows that we know what we need to do, but that there is a lot of work left to do it. But I think interestingly, it also argues for the repatriation of the extraction industry, so that we bring the extraction industry for rare metals back to Europe, back to the US. And interestingly, I think this argument would bring together two very different constituencies of political people. For the hawks, on the one hand, it would be a strategic thing. If you want to guarantee supply of these critical minerals, then you have to bring production back to the US or to Europe. And for the more environmentally minded, a different group entirely, or the more humanitarian minded, it would be a question of not exporting our pollution and our worker health problems to other countries, but rather extracting the materials in our own countries, putting the proper regulations in place so that everyone and everything is safe, and guaranteeing things that way. So I think a political consensus around extracting rare earths can be found. Extracting rare earths in Europe and in the US can be found. I just hope that companies and consumers are prepared to pay the little bit extra required so that we can mine these minerals safely.